Right, as post. Will have. Cool. Right, so last stream we was trying to get some more of these detail material uh spheres. Okay, I think it's crashed. Maybe. No, cool. Yeah, so what we have is like this box at the back. It's just a cube, but we already march into it. And that's called a geometry material. And it's just a procedural material shader which runs when we do the shading pass. And while we're doing the shading pass, we want to add ways to put more detail on this. So I'm trying to call this thing a detail material. And the idea is inside the volume of the material, you're able to put some spheres down, basically. That's the idea. Sphere volumes down on the surface, and then march or ray trace into them depending on what's inside that volume. So it's a different material. So we've just been doing it in 2D at the moment, just trying to get that sort of ray marching through the grid code and doing some spheres. But we got to a point where there's just like a list of things to do now. And what we're doing, so this will be graphics materials. Here, so there's these things which is left to do. And I was thinking actually off stream that we might, like currently we do this all implicitly, like these spheres are all placed down within a grid automatically, just procedurally basically through code. But it got me thinking that we might want to shift this into being placed down through code when you're inside the editor, but maybe the positions will be passed into the shader explicitly. I think we might move into that approach because it allows us to sort of have an artist come in and sort of like place where the final spheres go, and it could be quite well. It's what you'd want, right? You would want as an artist, you would want to have tools which sort of do stuff automatically, but then allow you to tweak it. So I think we would go for the latter approach. But yes, we'll just do a quick prayer and then we'll start going down the checklist, ticking stuff off, and then get to a hopefully get to that place where we feed explicit sphere positions in from the CPU side today. That'll be what we end up doing. But any questions, feel free to ask away. But yeah, let's do a quick prayer. Our Father in heaven, thank you, Lord, for this day. We bless your holy name. Thank you for providing us everything we have, the breath in our lungs, the sunny days, even the rainy days. Thank you for, our our spouses and our children and our family who's still alive. Thank you for providing us also for the time that we live in. We've access to so much knowledge and information, and we have warm showers and just amazing time to live. Help us have a good time today, successful time streaming. Help us, go down the right path and not go down too many paths which stray off into unsuccessful paths. Help us all down the lovely straight and narrow path to success. And I just pray for each and every one of my viewers, Lord, that anyone who's not saved yet, Lord, I pray that their hearts be softened to the gospel and they receive the Lord Jesus Christ and that perfect blood sacrifice as their payment for their sin, past and future. And I pray they just wake up and see the times that we're in, and the time of your coming is just so near. All the signs are on the wall, like that writing's on the wall, as they say. And yeah, cannot wait till that comes. But in the meantime, we shall keep doing your will until that time is come. Thank you, Lord. In Jesus' name we pray. Amen. Cool. So, hope everyone's having a good weekend. And today, let's start off with this checklist. So, the beautiful thing is we've done this debug view in 2D so we can get all the bugs lined out of the way and it's not going to be basically dealing with print statements and stuff like that, right? So some data is better visualized, other data is better printed out, right? So we'll probably try and keep this code around such that we can always like bring it back if need be. But it probably won't be completely functional via an if statement, maybe. I don't know. We'll see. But yeah, highly recommend you build something like this when it comes to doing complicated things in shaders. So the black box is the material space, -1 is bottom left, +1 is top right. And so this in the background you see this sort of brick surface essentially, and it just so happens that the -1 is the bottom left and +1 is up there, so this kind of maps into that space ideally. So the brick surface will be somewhere around here like this basically, yeah. Now what we're seeing is a ray going through the middle of the box, and we're just randomly placing spheres down in each grid cell. And this is where it's just currently working. The ray technically will come from the outside going in, but yeah. So what we want to do is just make sure we're handling all the edge cases basically. So the first one on the list is check ray going outside the bottom left of the material area. Thinks it hits a cell, it actually doesn't. So yeah, this one here. What is that? Or maybe it does. No, let me get a flat piece of card. Let me get a flat piece of card. Let's see. Doesn't seem like it does. So I think what it does is it goes out of bounds. Sorry, my son's coughing. BRB. Okay. Right. So I guess the question is, like, we probably won't comment out this stuff. 14 is the grid dim. What does that even mean? So we should be seeing 7 as a half, right? 1, 2, 3, 4, 5, 6, 7, right? Because here's the middle. That's fine. So cell chord +7. Okay, so I'm not sure why that's happening. Maybe. Yeah, I wonder. Yeah, so what we can do is we know we know the position, if you will. So it's a 137, I think it is. So right, so here's 0, 1, 2, 3. Oh, 037. Yeah, so this 1037. So if 03, can you print out the let it shine. 0 and So y equal 3. Now, we want to see it do something like, print out. Let's do less than or equal to 3. Yeah, so there's 2 of them showing up now. So what is it doing? So what would it do? Yeah, so it should break out, right? Um, oh, so it hits that. I see. So as soon as it hits this side here. No, it hits there and then, hang on. Hits there. Ah, I see what it does. Right. We got it. So it's kind of obvious when you think about it. The ray origin's here, right? So ignoring all the other boxes, we get to, when we've reached as far as this box, all right, let's talk about the box before. So this box here. So it's sort of like it's finished ray tracing into this box. So it does and it's sitting here. Well, okay, after ray tracing this sphere, it ray traces against this box that it was in, and then it puts itself here or something like that, right? And then it ray traces against this sphere. And then after that one, if it doesn't hit, for instance, it will carry on by ray tracing against this box again. It has a near point and a far point. So because there's a far point, it then ends. But then why does it, when I line it up on the camera, on the screen, oh no, I guess it does actually, it goes down. Right, I guess it marginally, yeah, it does, it marginally gets to that corner thing there. So that's not a bug, okay. It marginally gets to there and then, right, okay. Right, so that's not a bug. We can check that one off. Try starting the ray outside the material space. That's a good point. So the ray is, it's just hard coded. Let's just start this out here, say. So let's make it 1.1. What does that do? Right, completely broken. So usually when so what we could do is just clamp it at that point. So 1 is fine, right? So I guess something we want to try and avoid. Yeah, so maybe a safe thing would be just to try and clamp it. Something to think about. So why doesn't the code work again? Because, oh, because it expects it to already be inside one of the boxes. Right, that may or might not change later on. Anyway, let's get rid of that, that's fine. Right, only accept spheres when they meet the min overlap requirements below. Yeah, I think we're going to be removing that. In the near future. Let's skip this one for a minute. Reject sphere smaller than a pixel. Again, that's an optimization for later. Okay. So work out how to support changing a detail material over a mesh without getting half the rendered objects. Yep. So I think this gets us to the point now. It can have multiple layers of different detail materials and different kinds of detail materials. Yeah, so I think this is now getting into this new sort of slightly new direction I probably want to go in. But it's cool. So optimize code functions. Oh yeah, we can get rid of that one too. Great. So our light is still in this room. We're still got enough light. Good, good. So effectively we've got this box in the background, right? And we want to add little bounding spheres of some other material. Just we're calling it a detail material. So inside that bounding sphere could be like moss. It could be like, what else could it be? It could be pieces of grass. It could be stone. It could be sand. I don't know. Something three-dimensional volume that you ray march or ray trace into. So we are currently spawning them inside of a grid implicitly, and it's got the benefits of we don't have to store this information, but it's kind of got the downsides of you basically have a bunch of sliders to tweak, and that is all you can do. So the sliders are great and they're powerful because it means you can just like get something up really quickly, like filled with all these spheres, and then amazing. But the downsides is if you want to tweak individual bits of it, it's not going to be good for that. So, you know, as an artist trying to make something cool that they like, they would like the fact that they can quickly get some stuff by getting some sliders in and, you know, just arting up the whole thing. But then also, it will kind of suck because they can't go in and be like, that bit there, I'd like to just move there or rotate here, or you know what I mean, just or rub that bit out, right? Or only put these bits inside the grooves here, sort of thing, right? But not on the surfaces of these. And there's only so far as parameters like these can go, right? So there's like a denseness parameter which defines how dense the grid is. That we're placing them down on, right? There's sort of a min-max radius, and there's like a min overlap, which allows it to like embed itself on the surface. Like how much should it be embedded on the surface before it's accepted, right? Now, what I'm thinking about doing is keeping this stuff, but for the editor. So the editor, when you sort of are making stuff, this is like this is like a mode it could be in. But then always underneath it will output an explicit list of spheres. So it has a downside of having an explicit list of spheres. And you've got to read that from memory and all this. But it's going to be completely tweakable then after the fact. So after you've done all these sliders in the editor, you can be like, right, I want to change this. Or from the get-go, you can be like, no, I don't want that. I just want to place some bits here, right? So this is what we want to do because it's going to be the best way to get exactly what you want. That's the plan. All right. This is going to be amazing. So let me just get the line down. But I still think, right, keeping this grid is going to be great because at the end of the day, I was thinking today, oh, this means we've got to do like a quad tree or a BVH, and I'm just gonna have to rewrite the code I've just written. Then I was thinking, hang on a minute. Quad trees and BVHs are kind of cool, but they also kind of suck. Like at the end of the day, that you want they're called an acceleration structure because they're meant to accelerate the rendering, right? And for this particular case, I don't think it's going to accelerate it more than a grid. Because the best thing about a grid is that it's uniform. And so that means you can just assume loads of things and not have branchy code, right? And it's awesome. Now, a quad tree and a BVH means you have to have a stack to go back up the stack and things like this. Well, not necessarily always, maybe on a quad tree. Sorry, an octree. 3D, an octree. But then you kind of also have branching because different pixels in the same wave are going to go in different places and yeah, wait, would you get that in a grid? Yeah, you'll get that a little bit in a grid, but it might not be as bad. So a grid would diverge. You just step to the next box and then you'll go over a different set of spheres though, sometimes. Yep. But with an octree. Yeah, so the thing that makes the octree bad. Yeah, so you still get the divergence, but the thing that makes the octree bad is you got to go through the depth, and a BVH bad is that you'd have to go through many different depths of the octree to finally get down to the base where you've got all your spheres, right? So the basic idea, if I can screenshot this, it's gonna be overexposed, but let's go. Then we can do some drawing. Hang on. You're gonna give me the I want to see the finally. Right, so here we go. Now, so basically inside here, there's going to be, can you see this brick thing in the background? If we was to draw this into here, it might be something like this, right? Where it might be, just like a brick. It's a bit, let me try and make it a little bit more. Something like this, yeah, but then just going all the way around. You get the idea. Now, this one's going to be accepted, right? So that'll be a sphere that goes on the top. Now, if this was to be an octree, you might have to go like this, right? This is actually inside of a thing here. So you'd do a ray verse this thing. You'd be like, oh yeah, I hit it, right? And then you actually have to traverse down, and then you'll do a ray verse one of these guys, and then one of these guys. You know, those sorts of things, and go into these, right? So you're adding an extra ray which we didn't even need to do. And furthermore, if you have you put this into another layer of octree, because you might want to, like for our particular problem, it doesn't actually solve anything doing octree, or octrees. It doesn't actually solve anything because we're not going to be skipping that wide of a space. We're actually going to already be quite close most of the time because we're already near the surface. So the extra checks might be fine. I reckon as well we can fit multiple spheres inside of a box, and that will be all right. So yeah, and that goes same thing for a BVH, right? We're probably just going to be adding more Rayverse box checks just by having a BVH. So I think just a simple grid is just going to be fine for this problem because everything's typically near the edges anyway, kind of thing. But I could be wrong, and in future we can add a more optimized structure of that. is the case. But I hope the grid will just do. So I think let's design what this structure needs to look like. So we'll go to our graphics shared encoder files, because this is our serialization. So I reckon what we can do is say structure graphics VK, I guess we do. And then we say something like sphere or detail, call it detail sphere, right? We could make it a very long name like detail material sphere, but that would then be like really long. And this is all right, I think. So I reckon we can store these inside the, like they should be relative from the position inside the grid. So the U8 might be enough, I think. So stuff like this, right? So we might be able to go position or offset X, Y, Z, radius. So these are going to be -1 and 1. So that should be enough resolution. If it's not, we can up it. And yeah, but not -1 on the radius. Whoops. 0 to 1. Now, something also that we want is to specify the, is it called an accessor? I think it is. I forgot what I called it now. Accessor offset. So I think that's it. Anyway, so this will put these 3 fields as a single field. Well, they have a way to decode as a single field in the code generation. Now, is there anything else? Yeah, there was another to-do point, which was like, hey, we would want to support multiple, different kinds of materials. We would like to support, yeah, we would like to support different kinds of detail materials. So having a material ID or whatever here would be powerful as well. So that could support that. So you could have a piece of moss that gets placed down, or you could have a piece of stone, right? All in the same grid of things, which would be awesome. So yeah, I don't know. What do we call that again? So we called that a detail material, proto material index, I think we called it. So, yeah, but then you would need, yeah, then it needs some material properties alongside it, isn't it? What do we call, GPU material, maybe it's this thing, and then the property words, yeah, that would be it. Bam. So we'll call this what is the material to use, right? The detail material. So it's 32 bits. It's a little big. So we're looking at 8 bytes per sphere. So yeah, that's quite a lot. What would be better is having a palette. But obviously this is it's going to have to be 8 bytes though, isn't it? Because we've already used a word here, right? A 32-bit int here with the packing. And so if we're going to do any more data, it's going to have to be another full 32 bits there. Unless we're allowed to do, it was all inside a completely byte packed buffer that we did the manual, pulling out of, but that would be on the GPU, so it's going to be completely weird to do that, but it's possible. So yeah, that probably won't be very good though. I wonder what we could. I wonder what else we might want. I think that is everything that we can think of right now. That's good. Okay, so in terms of this grid, like another problem that we've got now, because we're defining them explicitly, is the fact that the grid has to contain an array of spheres. So, right, but it's not that much of a problem. Because I reckon the grid could actually be quite big. I'm not sure. Like, it might not be this small anymore. But when we try and randomly place them in the editor, we might use a small grid like this, and then generate the spheres on the grid with an offset, and then push them close to the surface. But then when it comes to the acceleration structure, it would just be a kind of a big grid. There might be some repeated spheres though, in places, but that'll be okay. Yeah, that's a problem. Repeats. Yeah, we'll solve that later. Don't know how we'll solve the problem. We'll solve it later. Right. So I think we can. That's a good one. I like that. So, right. So we also want like a homing spheres. Right. I guess the program just crashed, but that's fine. Homing spheres. So like, let's bring this to do into the graphics materials. Materials plan. Right. So we got a new thing now. So detail materials. Right, detail materials, here we go. So, HTML. Right, so work out how to support changing detail materials over mesh without... Right, okay, so in the editor... So, in the editor... something like this. In the editor, we will be able to place down, or we'll be able to automatically place, generate a bunch of spheres on the surface of a mesh instance. Detail spheres, we'll call them. On a mesh instance. If the user the user will be able to, although we can just say the word artist, or the designer will be able to, let's just say artist, right? Will be able to tweak the spheres after, sphere positions and rotations after. But you know, it will come at a cost of it'll come at a cost of either losing the spheres when the model is tweaked again, the model surface shape is tweaked again, or an auto adjuster which will not always do exactly what you want. Something like that. So that would be pretty cool. So you can have an automatic thing where it places down, but then they can manually go and tweak the spheres and things like this. And they should be able to go in and be like, right, I want this one. Right, we would also, we can also then assign a material to each detail sphere. Right. This, I like, you know, putting these bullet marks in because it makes it easier for me to read. That'd be very powerful, right? You'll be able to have a good thing about this as well. Be able to have these homing spheres, if you will. So, the editor auto generate will work by be able to placing many layers of grids with different densities and minimax radiuses, if you will. Yes. And then those could Hey 3D, how's it going? How you doing? Yeah, been a while, hasn't it? How's life been? Good to see you. The editor auto generate will work by placing, you know, a grid or a sphere in by defining, you know, one or more layers of grids with different properties. Different properties, you have like a denseness, min radius, max radius, min overlap, seed, probably a seed or something like that, and then maybe a seed, and then maybe, and also like a material, something like that, yeah. Something like this. And then now the beautiful thing is as well is spheres. Spheres will. So I think we'll have to send this off to the GPU. We'll have to have a job. Like the editor will have to be like, right, GPU, I've got this sphere position and this surface. Like, tell me how far away I am from the surface, and then it sends it back, right? It's going to be like slow, but we're doing it like, you know, we'll have like a bunch of them that get sent off, and it gets a bunch back probably. Actually, yeah, sorry, we'll have some latency, but we're doing a whole bunch of work actually. And we get sent back, and it's in the editor, so it's not a bad thing. And then we're not doing any of this code at live anymore. It's just pre-baked into positions. So that's another benefit of it. So sphere, detail sphere will be homed, will be guided. Detail spheres will be sent to the GPU to be aligned to the surface of the material, then sent back, and essentially binned into a grid that contains multiple spheres, right? Into the grid, this is the acceleration structure. Used wall shading. Cool. So yeah, so this way you can do many layers and different kinds of them. We end up, right, we need to optimize maybe, get rid of that. Reject sphere is smaller. Awesome, good to hear, 3D. Reject sphere is smaller than a pixel. Yeah, okay, so I guess we move these guys back and we'll just slap them in the to-do section of this this code here. Oh, right. So I think the thing we want to work on today is making it such that we can pass some spheres up from this grid, this acceleration structure from the CPU to the GPU, and then actually get it working. But yeah, the traversal code is basically staying the same. And I think we're going to find a way to comment out all of this debug stuff, or maybe leave it in there behind an if block, because in the future we might want to tweak this around and debug some other things which I may have missed. I don't think I've missed anything, but how things go. So having this debug code staying around would be very nice. Cool. So, yeah, I think in the material system, sorry, not material system. The material system at this point. So you'll have a mesh. Let's get up the rendering so we can see some things. So this grid, right, with all the spheres, is it going to be like, so per mesh instance that has detail materials, is going to possibly have its own set. But I guess they could always share sets of things, right? Like you might have something with the exact same set of detail materials on. So ideally you would want to share it, because then it's, after all, it's being stored in VRAM, right? The more data you can have shared, the better, right? So where does this go though? So it's a bunch of detail spheres, and so it probably goes in the mesh system and not the material system. But they do all happen in material space though. That's the thing. It happens in material space. Yeah, so probably what you're going to do is have a... So you have a mesh, and it has a... Well, you could hash them all up, and you could be like, okay, I got this range of spheres or whatever with this hash. Do you already have that in the system? Yes. Okay, we'll use those. If not, we give you the ones that we have. So it's like a deduplicated list of things. That could probably work. But I reckon that's probably it's probably another asset type. Yeah, that's probably where we'd do it. So these detail spheres inside an acceleration structure is probably an asset. So when you have a mesh instance that has these, it sort of essentially creates this other asset. But and the only way you can share it, I guess, is if you clone the object, and then when you start editing it, it's like a copy on write thing or something like that. So yeah, I think that's the only time. Yeah, so is it... So I know I said it should go in the material cache, but I'm considering the material... I know I said it should go in the mesh cache, but I'm considering the material cache should it go in there, because it's kind of a material thing. Right, it's like a detail, we can call it detail grid, right? A detail volume. And so we can support up to so many detail spheres in a system. Maybe. Yeah, I think we'll call it detail. Yeah, it's going to go in the mesh system. So, sorry, the material system. Words. Yeah, let's put it in here. So we'll call it a... But yeah, we don't really know... I think there'll be like some kind of like asset ID or something like this. And this asset ID is what we will use to deduplicate it. And so I think we can say material detail spheres cap. Now, say if you have, what's the maximum number of meshes we have? Isn't it like 4,000? And I don't think we've even sorted out the system, but it's probably like 4K, right? Let's just say it's 4K. So if you support, so say if we had a grid of, yeah, it's even a lot. So what 8 bytes per sphere it is, isn't it? So say if we had, let's just say 4K squared, right? That's 16 million, right? It's 16 meg. So then we times it by 8 bytes. That's 128 megabytes of things, right? So yeah, right. Maybe we should just say, right, we're supporting up to. Yes, that was 16 million. Of default, yeah. So maybe we can just say we can support 1 million. And that's 8 megabytes. One way of doing it. So it'll be so hang on a minute, that's too much. Yeah. There you go. Space is 1 million. That'd be cool. Would those spheres cover the whole object? Yes, typically they'll just go on the surface. They won't necessarily cover the whole object, but they'll cover a reasonable portion of it. It just depends what you want, right? You might want it to cover literally the whole object and do some sort of grassy stuff, right? Do some grass. That's one way of doing it. Oh, that's another thing. You could really animate these as well. That's another thing. But yeah, you could do like these bounding spheres could be like grass or moss or something like that. But yeah, this is how you can get stuff affected in the wind. That would be super cool. So, do we really want to deduplicate then? Because if we just made them unique. Yeah, like so currently imagine if you've got this brick structure and you're going to put some moss down, well you can put some patches of moss down, and so the spheres won't necessarily cover the whole object, but they'll be around, or bits of stone, that sort of thing. It's rather interesting. To say if we had ones which were affected by wind, you might want to animate them. So deduplicating them might not be what you want, but then again, some things it will, right? It's the whole sort of static versus animated mesh, right? It's the same sort of thing, isn't it? So you probably want to have, yeah. So I think later on we'll just add a system where you basically could take a copy of these detail spheres, and the positions will just be, or the rotations, and that would be, yeah, modified. There'll be a copy elsewhere. Okay, but yeah, that's fine. So we probably want to add some kind of like, I guess, object pool for a call it detail grid. So let's just say there's like support for like 4,000 those detail grids. Yeah, so the detail grid, you can have a range of, so we'll use this sort of like range block allocator thing. So it's just a heap, like a free list allocator, heap allocator. So we just got a buffer on the GPU and we've just got ranges of memory allocated. And we're just gonna have, that will be the spheres block. So the detail spheres block. You probably just want a ref count. That's about it. So we'll need an object pool, and yeah, we'll do a detail grid. Okay. Oh, this is gonna be cool. So we also need a array of, so the property was allocator. So then we'll need a spheres, detail spheres allocator. And we'll also probably need, so we could have 2 copies. Yeah, we could do a similar thing, right? Where we basically just have them all allocated, and we just flush a start and end range every frame. And that means we just maintain 2 copies. Yeah, when it comes to dynamic though, yeah, let's just do this the same way. It kind of sucks though, the dynamic, but we'll solve that problem when we get there, you know? And it will mean that we have 8 megabytes on CPU and GPU, and they basically store the same stuff. You know, it would be when the CPU is not really using it. You know, instead we probably just have an array of like an upload array, where we basically just stick it in a temporary buffer somewhere and yeah. But that's what we probably, yeah. I don't know. Anyway, let's just keep doing it this way. It will solve the problem for now. So material cache, allocate material cache detail grid allocate. So we probably want to map some kind of like yeah, I think we'll keep it to like a name hash for now until we can store these things. Hey there, Cat Payne. Would you still like me if I told you that I'm starting to like CPP a little more? Oh no. It's okay. I just you know, everyone has to go down their own path in life, you know. And sometimes you have to try these things out. What stuff do you like about CPP exactly? I can smell it already. It's the templates, isn't it? Namespaces. Oh, namespaces. Just namespaces. You're not one of these people, are you? Class. Wait. Anyway. uh, um, I don't know. Namespace is kind of pointless, right? Like, do you do a lot of using namespace? Is that why? Is that what you're thinking? But then, so the thing is about namespaces is, like, this is the reason why you have to stick with C, because you can just do a simple string search and voila, you found everything. As soon as you start using namespaces, it's like using graphics VK material cache, right? And then no longer, so do you have to do that? Or no longer do you need to do that? You can just do this, right? If you will. When you're using it, right? That is, of course. You can just do that. But then, like, when you've got this, what does this even mean? Right? No longer can you just do a simple string search. You've now got like a gazillion different other things which match that. And Yeah, you better hope your text editor is handling all that stuff properly, because sometimes it doesn't. So simple string searches feels more organized. Okay, it feels good. It's a feeling thing. Okay. Feeling thing. But yeah, I think practically speaking, they kind of don't solve any problem. Really. My feelings. Yeah. Same with like methods and stuff. Like, the most annoying thing is this object dot init. Right, I know it's proper English, but like when I try and find the init function, there's like a gazillion other entries, and I'm like, my text edit. Sometimes the text editor doesn't do it properly, and it's like because you've got your code is kind of syntactically a bit broken in some place above it, and then it just doesn't find the thing. Or the text editor doesn't have all the macros properly handled, and it just throws it off. But yeah, CPP. Why you just stick with C? Shine, let it shine. It's not a man, let it shine. Now, we want to pass in a whole bunch of detail spheres. Now, we could just hash them all up. Hash them up, and that will be the thing. Yeah. But actually, to be honest, this is going to be a packed one on the GPU. This is going to be the packed one on the GPU, so we want like an unpacked one. Which is not fit inside of an acceleration structure yet. So those be saved as in the file. No. No, so when the editor loads it up, it will make them. Yeah, actually, no, this is fine. Cool. So you hash them all up. And now this is the way it's going to work. And then you get back your grid. I don't think you need to care about anything else. Right, let's just get that working. So, object pools. Shine, let it shine. Cache material detail grids. Nice. Grid. Lovely. Awesome. So reference count, I think that's going to be 1. And then the other one is going to be like, hey, the spheres range allocator block. So, well, that's a good point. So do that first. So detail spheres allocator spheres count. And then if not, you just return a null ID. And then yeah, so we might want to we're going to want to deduplicate it regardless of what. Yeah, so we're going to need some kind of hash table. I'm thinking about just settling for a hash of the spheres for now. Detail grid ID is spheres hash. Cool. ID from so grid ID. This material cache is kind of doing a few things now, but you know, maybe I should just call it a detail sphere cache and do a whole separate thing. But anyway. Maybe this could be a whole sort of nah. Can't generalize it though, because you know, have a hash table and then an object pool and then a bunch of things. But if I do that, we're not going to be able to specialize it for each case, which will be different always. So it's best to always manually write it up. All right. Lovely. Now, that'll do for now. So, essentially this function might as well return probably an OS result, I think, because that can give us a, or it could just give us a true false. Right, so that'll then mean return OS result. Oh, is it like an error? Yeah, so we could say like, you know, out of memory is full. Something like that. So we can return an is full for like the object pool as well. What do we do for? Yeah, we didn't really handle that case here, to be honest, either. That's another thing. But yeah, so if Cool. So the other thing is the hash table. So get this one here. Is new detail grid ID, because that's what's stored in the hash table. So it'll be a detail spheres hash grid ID from. Someone help me out, please. Grid ID from detail spheres map, right? So the spheres hash just goes in here, just got to work it out. Then is new. If it's not new, then OS success. All right, so the spheres hash. What is that anyway? Is that U64, U32? Ooh. Yeah, 64, cool. So spheres hash, just chuck into an FNV hash 64, spheres, spheres count times by size of dereference of spheres. Or spheres 0, make it a little bit easier to grasp that. Then the initial is obviously the hash 64 in it. Lovely. So then we've allocated the block. Spheres block goes in. And voila. Return success. Cool. Now we just got to initialize all the values. So yeah, should I? Yeah, we did go a bit fast there. Is there a better order this could be in, really? Like, we should probably put all this stuff together. Call it detail grids pool. And a detail grid from that. There's all the detail grid related stuff. I think that will be a bit easier, a bit better. And then we can take some of this and instantiate it together down here. So yep, they're all good. Detail grid, lovely, cool. So the other thing we've got to allocate is the array of so it's graphics VK detail sphere. The detail spheres, so the range of those guys. There's also another thing as well we need to put in there, and that is actually the detail grid. Ranges. Yeah. So yeah, ranges of spheres and stuff like. We could probably do a U32 per grid cell. Hey, Avalanche Pointer. Yeah, I don't know if there is a benefit to namespaces. I went over and tried to talk to him about it. But yeah, I got a response of it feels more organized. Like, it just makes more code unreadable, I think. You can't find exactly what the function is called in someone's code base you don't know. When you try and read someone else's code base, use namespaces or like, it's like trying to read Rust code. It's like so many functions are just called, you know. Yeah. Very short names. And you have to and there's tons of the same names everywhere, so you got to find where the definition is for the function. It's horrible. That's why you have to download like the code, put it in an IDE, and then hope it works. Whereas if it's just strings, you can search it. It's amazing. But yeah. Yeah, so we need those, I guess we'll call them detail grid ranges allocator. It's a range of ranges. So detail grid allocator, okay, we'll call it sorry. Yeah, ranges, okay, we'll do that. So that means actually, this needs to have passed in your grid ranges. All right, so there's more things which go onto the hash. So it's no longer a detail spheres hash, it's actually just a detail grid hash. Cool. Right, so you'd basically pass that in here. So you'd do a grid ranges. And then you generate yourself a right, you need to allocate 2 blocks. So grid block, if you will, probably. Grid ranges. Yeah, I wonder if you need to know like the dimensions of the grid as well. Yeah, where's that stored? We'll find out. If we need any more parameters, we're definitely making a spec structure. All right. Ooh. Yeah, technically there's some problems here where stuff needs to be deallocated. But can't be bothered right now. Yeah, there's a future Henry problem. This will be fun. So yeah, because I'm probably gonna have to come in here and handle the dynamic case anyway, so it's all right. Let's just get it going. So initialization code would be initialize the grid. Where's the free range allocator? Right, so the range is so say we did an 8x8. 8x8x8. 512. Let's try that. I'm not sure what it would be, but let's just imagine the average is that. Maybe. So range allocator, let's get one of them. So the number of, what is it again? It's the capacity, the number of blocks. That's the capacity is detail grid ranges cap, and then the number of grid ranges, isn't it? Sorry, detail grids. Yep. So we'll do the first fit, that'll be fine. Next one is the number of spheres. Detail spheres. Cool. Nice. Right, so that's that done properly. We still need to allocate these different ranges and stuff. So we need a spheres buffer. And a grid ranges buffer. And where it's changed at the start and end so we can upload it. Hey JD Husk, could you go review the wave system? Potentially. I've not really written a wave system before though. How are you doing it? You doing it via mesh? I've just looked. I looked at it not too long before the stream. Briefly. Oh, have you taken it out? It's not on the Discord anymore, is it? Or am I looking at the wrong chat? Anyway, can't see it anymore. But yeah, I've not really coded a wave system before. Not really sure. Are you doing? Is it a very highly tessellated mesh, or are you doing it a different way? Yeah, so we could make this into a system where we like, basically call it I don't know, an upload buffer, if you will. It's probably a bad name, but or a mirrored buffer, right? And you mirror it. But yeah, I think some of these need to be solved differently rather than just like mirroring it between CPU and GPU. Sometimes you might not want to have. Yeah, I think we might want to make it such that these. Yeah, it's just not really worth thinking about this problem just yet. For now, this will do. Detail spheres. That's all right. Now, where's the buffer? When did the buffer get initialized? How bizarre. Alright, I guess initialized here. Detail grid. It's called it ranges. It's horrible. Corrected. Okay, so this is spheres. Let's reorganize that. Oh yeah, so this is actually explicitly done. That's the reason why they're outside, but we don't need an explicit ID. But hang on. Yeah, we want it to be an explicit buffer ID because that would then mean like a descriptor index, because then we don't have to keep passing it up. That'd be amazing. Alright, let's do another one. Forgot about this. So from the shader we can just access it with an index. Just have to make sure we explicitly synchronize. So material detail grid ranges, detail grid detail spheres. Nice. That would be awesome. And that will then be a G graphics VK detail sphere. Where is it? Nice. Lovely. Amazing. Right, so we just got to now follow the upload code. For some of this stuff. So make sure these are all right. Oh yeah. Thank you for the type safety there, big up. Lovely. Now, next thing is so when we initialize a frame, we're gonna follow these guys around. Yes, when we instantiate a frame, we've ideally got to do these things. We reset them. These are like a range in the buffer which have changed. So we reset them to this, but the start is after the end. So it means that we don't have to upload anything. But as soon as we want to upload something, we modify those to, hey, upload this range. So it's just trying to mirror the buffer. So hopefully you only upload some small section, then you upload less. Hey Judy Husky, I saw I've just deleted any Discord because it was the wrong channel. Oh, okay. Yeah, okay. Yeah, no, I'll look at it. I just yeah, I was just busy today, Um, I was at church today and spending time with the family. But yeah, post it in the right channel, I guess. It could be in discussion or the show your work channel. It doesn't matter. And the graphics one is fine. But yeah, posting there, I'll take a look. There is some, yeah. I've not really done some waves and stuff and water, but it would be something for me to look into. I'll have some questions about how you're doing it as well, because I don't know. Frame init, upload. Yes, where else are they basically? Just upload, right? Right, and the store properties function where it sets it, but for right, so basically, if this is less than that, do it. Now, copy 3 times. Prop words. Detail grid ranges. Voila. Detail spheres. And voila. Now, it should be size of U32 though. That would be a copy paste error. So it's got to be a graphics VK. Yeah, that would have been a bugger to track down, maybe. All right, cool. So the next thing would be storing. So the material have a way to store properties because you basically have material objects and you can probably change it over time, have dynamic materials. I don't know how that will look, but you can probably do that. So we've added support for that, but we probably don't want that for the grid. So the way the grid is going to work is Hang on a minute, this didn't up the ref count. That's a very good point. Oh no, it should only up the ref count if you want to do that. Anyways, future problems to solve. How should we handle the ref count? Right, so we want to get the block. We've already got the blocks, that's good. So start end. Just take prop words and just put them in a put that in a lovely little block. So this prop words thing, just take it. We'll have the grid ranges. Awesome. Yeah, it's kind of late here anyway, but I'll have time over the week. That's for sure. Just post it and I'll take a look when I get time. Right, so what is going on here? So... Oh, it's called it grid ranges. Right, grid... And then... So min-max. Now the grid ranges got passed into the function. And that's a grid ranges count. Lovely. Oh. What's this times by U32 stuff? Because copy element is supposed to be doing... Hang on. A word is a U32 and this is already a U32, isn't it? Yeah. So that was actually copying more memory than it was supposed to. Right. This is alright. Yeah, so all this copy element it does, it's just a mem copy, but it does the size of automatically. I got quite a few of these guys, you know, they're quite handy, like 0 an element, 0 many. You can one it as well. Right, 0 an array. Right, compare, that sort of thing, right? Nice. Lovely. Lovely. Okay, so I think that's in a good place now. So this should be uploaded to the GPU. Cool. Now, we need some test data. So the grid needs to be given to, or the index of the grid needs to be given to the mesh instance, and then we should be able to have access to all of these things on the GPU. Yeah, that's basically it. So let's find where we do our mesh cache alloc, one of these guys. So we'll call this a Something like that. Nice. Now, here we go. So I'm going to get the grid ranges. Probably some kind of array count grid ranges thing. And then spheres. And then spheres. Some of that. And then the place where it goes can go into some global position called test material detail grid. ID is a bit long, but there we go. Nice. So we want to be able to basically pass that into the to the mesh instance and store it in the mesh instance structure, so it can be accessed. Cool. So we can just make a couple of spheres. We can put them like basically snug right up against the the top, bottom, left, right, near, far, and just see how they look. And we could probably have a single grid range, and it just covers the whole area. We are going to get only 256 in that area though, but yeah, only 256 like different positions across that whole area, but it should be completely fine for this test scene. Obviously for something more what's the way of saying? Right, it's not going to run now. But for a bigger mesh instance, you obviously want to have like a lot more grid cells down, because then the spheres are relative from the center of the cell itself, the grid cell itself, right? So yeah, we'll need to probably define how big the grid is as well and pass that up, but again, we'll find that out. Right, just gonna take a quick break and get refill the drink. We'll carry on. BRB. Welcome back. Welcome back. Cool. So, range of grid ranges. Now, the thing is about the grid ranges is we'll probably store the number of elements in the low 8 bits, and then the sort of start index in the higher 8 bits. So really, it should. I know it's a very simple decoding, but really it should have one of its own code generated things. So detail grid range. Bit long, but there we go. So you have like a count, and you'll have a start index. This be a spheres. Something like that ought to be good enough. Then, really, it's still a U32, right? Don't get me wrong, but hang on. What? Alright, is there any times by AU32? Gotcha. Now there's the other range buffer thing. That'll be cool. That's super awesome. Now, where was we? So we want to like initialize. Here we go. So the ranges. Now it's just gonna be 1, and it's gonna be something like well, it's not code generated yet, but you can't really get yeah, I think we'll just manually hard code it. So if we'll just make it 8 things we need, right? There's 6 sides to a dice, isn't there? So the next one would be the spheres. Now the things about the spheres is they're actually the detail spheres is we're going to have to manually poke those. Unless, yeah, we're going to have to do that. Yeah, it's not too bad though. But yeah, so sphere, you have to do something like a graphics. We have to use the code generated macros. So offset, set. So we do like a sphere. Spheres. This, and the offset would be, well, you're in a ×3, so one will be X. I think you just do a 0, and then we can find and replace all of it, which would be kind of cool. And there'll be a radius as well, I think. Hang on, so that'll be so radius, like, I don't know what is a good radius value. I think it'll be a 0 to 1 based on yeah, let's just make it 1. So it's the maximum. So 1 doesn't mean the whole of the area of the material. It means like there is a min-max value stored somewhere. And I don't know where that is. Maybe it's stored in the detail grid. I don't know. We'll find out. Yeah, we'll find out. So there was also one more thing, and that would have been what is the material? Do we even have that yet? We don't, do we? That definitely needs to be set at some point, though. Yeah, we don't have one yet. We only have the brick, but that's not a detail material. That is a... Yeah, this will come later. We'll need to set this, that is for sure. Equals something right to do, yeah? Now, we've got to do that 6 times. Oh, we didn't change this. That is a rather good point. Hang on. We didn't even copy... Oh, yeah, we did. Good. Nice. So... 3, 6. Lovely. I was going to find all the zeros and... Right, so 2, 3, 4, and 5. Now, with the other zeros, so we want a 1 along the x, then a -1 on the x, 1 on the y, -1 on the y, positive on the z, negative on the z. Cool. So on our cube, we're just going to see 1 on each face in the middle. Now, what else do we need to do? So that should all compile and run. Now, in the shader code, we need to actually go and start using this thing. So I've realized I've missed out on a couple of things, like how do we know the minimax? How do we know what the maximum radius is, or the minimax radius, so this 0 and 1 can sort of like map to that properly? And also, like, how do we know the size of the grid? And I'm sure that grid is just going to be a single value. So I think this range thing that it's got, these grid ranges, that's probably just going to actually be a bigger structure. And then, yeah, so let's adjust that. That shouldn't be too hard to adjust. Hang on a minute. I'm glad I chased it all down already. So that would be in shared encode. So it's just going to be called a material detail grid. And so we'll probably have a U32. We don't need a full U32, but anyway, what do we need again? We need the grid, and like how big is the grid? Oh yeah, and what is the min and max range? Yeah. So let's just do 8. Let's see, the most you can do is a 256. We want to keep it square. Do you want to keep it like cube? Probably best. Yeah, let's just keep it a cube. So that'll be... So we did 256. That's going to be a lot though, isn't it? There's 60 meg. So, yes, the point even up to that number is, kind of crazy. So we probably Like 64 times 64 times 64. That's 256,000 kind of thing, right? It's 256k, KB. Well, it's not KB because it's KB times, yeah. Yeah, so ideally you probably want to go no more than maybe 32 or 16. So 4 is 16, right? So we'll call it, so 4, so we'll call it grid dims, dim minus 1. So how you get dim is you just add 1, right? You can never have a grid which is 0. So because this will be 0 to 15 and we want 1 to 16. There's that. We also want a number of a number of yeah, a certain number of bits for the size of a radius in material space. So that'll be min radius in material space and max radius. Then, so you've got 4, and then plus another 8, 12, and then another 8, 20 bits. It's got like a 20 bits left. So we can just do that unused. So right, 20 plus. Oh, no, sorry. Uh, 16, 20. Yeah, 12 bits left, isn't it? Yeah. So we just call them unused. Nice. So that's actually what we have here instead. Just a little bit of a rename, no biggie. Right, so it's no longer called grid range, it's just called grid. So although we'll need the ranges. Oh crap. Actually, we need a third thing. Yep. Okay, my mistake. So this is the grid metadata basically. Hang on. So we need another one of these. So the grid just contains the data about the grid. The ranges that of spheres in each grid cell. And then the actual spheres. Cool. Right, graphics, shared, encode. Right, so kinda got that a little bit wrong. Yep. Hmm. Right, so I think, I don't really like having like tons of parameters. It does kind of suck. So I think we want to have another structure. Call it a grid spec. So it's going to basically be them all in here. That way we've got like named parameters basically, if you will. Okay, so grid ranges. Then you want to have your grid data like how many, what is the dim? Hang on. Shared encode. Yeah, the radius min and max. Nice. Cool. So that's what we'll pass in. Now we need to add another, oh crap. That kind of got changed with it. Yeah, one of those is packed and one of these is, this should probably be called packed at this point. Or GPU with a GPU thing on the end. Anyway, I don't know. Hey, this is the GPU one. Anyways, now so we need another one of these. Not too bad to sort out. Nice. Oh. Right, so we checked to see if it can be deduplicated. Now, that needs to have all the parameters in that properly hashed in. So that includes dimensions. Now the problem with yeah, you actually don't need a range allocator for that. Because you've already got the pool allocator, which gives you the index. So ranges, yeah, you just need a start end. Cool, that's fine. Now, I reckon you can compute the packed thing here. So you do a graphics VK detail grid. No. GPU. Let's call it GPU. Now, GPU bit field equals 0, so I guess just initialize 0 up here. Nice. Hey, analyze code. How many is in code inside CMD? Basically back in the old days, before I was born, and probably before you was born, there's text editors were inside command prompts, were inside terminals, right? And there was a famous one called Vim or VI, Vim. There's other ones as well. And so this is a kind of a modern one called Helix. And it's a modal text editor. So it's inspired on Vim basically, but it's more modern. I like it because it's got a single file for a config, right? It's not got like a programming language or a config file. That's why I like it. So basically, rather than start when you type, it just emits characters. Instead, when you've got the whole keyboard as shortcuts. So when you press a button, it kind of does a shortcut. And you have to press a button to go into an insert mode. And that's what a modal text editor is. And they're pretty cool. But yeah, so you just run the program and it just, you know, minus win. So that'd be spec dim, take one. Min radius, max radius. It's all code generated, right? So it should all sort itself out. Then you want to hash that guy. Lovely. Lovely. Now. Oh, that's interesting. I'm glad we caught that problem. That would have allocated far too much. Use VS Code. Nah, you're not a player. That's fine. You know, I'm not a fan of it, to be honest, but, you know, people use whatever makes them feel comfortable. Like, for me, the most kind of upsetting thing about VS Code is it's like a web browser, you know, to edit code. Like, it would be cool if we just had like a native program, you know? That'd be cool. But no. What's this complaining? Oh, it's down there, isn't it? Of course. So we want to add another one of these where we poke into our mirrored buffer. You know, we could probably make an abstraction and call it a mirror buffer, but yeah, where it's automatically mirrored to the GPU, but or you have some convenience functions, but I might not want to do this for everything. So I'm just gonna do the copy paste way. It's all right. Just trust me, it'll be fine. All right. So basically, your start is gonna be ID, so it's like core object index mask, that's the one. So I want to do like id.raw and that. Then it's just start +1. It was copying a single element. So, is there even a thing? I think so. No. Yeah, copying an element is just the assignment operator. Mind blown. So let's be GP. Then, voila. I think so. It was called it grids, that's why. But I don't like that it's a web browser, but coming from VS Code. Oh, you come from Visual Studio, so it's relative. Yeah. For some reason, Visual Studio just got so big and bloated. Obviously, they switched over from C++ to C#, and they probably went full OOP. And you know, obviously, can you imagine that code base, man? Oh, horrible. Yeah, there is the Z editor. I did try it out actually. It was alright. It did feel a bit like it needed stuff. It needed it did feel like there was still a bit unpolished, if you will, but it was alright. They also like really went hard into AI, didn't they, lately? Obviously, yeah. Sublime Text, just get rid of all the AI. Yeah, to be honest, that text editor was like really popular for ages. I don't know why people went to VS Code from that. You know, I'm not a fan of Python, and you know, I know Sublime Text is configured with or has extensions through Python, but as long as I don't have to touch the Python, I think it would be fine. Yeah, I much prefer the modal stuff, to be fair. I just like being difficult. But yeah, I would say Sublime's, you know, I think that was one of the first one. Yeah, it's not the first. I think maybe TextMate did it, but they did like the multi-cursor thing like really well. Then it took like the editor from. Then it took Visual Studio like until was it Visual Studio 2023 or something like that to get proper you know, multi-line editing thing. Multi-cursor editing is horrible. Absolutely horrible. Cool. Cool. Okay. All right, so. Nice. Now the next thing. Oh, yeah. All right, so we need as well. Some of those. And the buffer. We not have a number. Oh, grid cap. Single. Man, I can't believe I did that. I didn't pluralize it. Lovely. Now, we need to find where we initialize those buffers. Okay, where is our props word buffer? That's the one. All right, so we need, why aren't you a, oh, okay. Thank you. Nice, so let's get rid of the range. Nice. So we got explicit placement of the descriptor, so we can just use a constant inside the shader, so we don't have to keep passing the ID around using bindless and all that, you know. Cool. Now, let's wrap up by doing the initialization. Hang on. What are you complaining about? Oh, the GPU structure. That is fair. Oh, crap. That is a good catch. Nice. So right, we just gotta call this function properly now, and then we're done on the CP side. Right, simple bat files to build. Yeah, I use a very simple bat file to build my build system and then run it. My build system's written in C, right? Everything in C, and then a simple shell script, right? Just to compile it and run it. All it needs to do. Yeah, I don't like when you go into a code base and it's like, you know, filled with tons of different languages, and it's like, but aren't we like really good at using C++ or whatever, or C? Can we just use the same language everywhere? But yeah, I know it's a little bit more a little bit more friction in C to like do stuff sometimes, but you could just have a core file filled with like all of the utility functions to make the programming easier, and then it just becomes like basically like every other language, you know. I think if you great. That parser Helix uses seems interesting. Tree yeah, it's all right. It does the job. You know, Tree does the job actually. Yeah, but the LSP stuff is like, ugh. That's my one gripe about it. I would just love a dumb, stupid string suggesture thing. So like sometimes this stuff doesn't work, the IntelliSense, because my file is like not in the perfect syntax, so it just gets thrown off. And I just love a plain stupid string deduplication searcher thing. That thing I like. But Helix does it with the LSP. But Teresa is good. It does the syntax highline pretty well. I think if you ignore the AI, I think if you ignore AI too long though, professionally, you might get behind at some point. Could be wrong, but that's how it would be once AI gets a bit better. I think by the end of this year we'll be close. Okay. So basically, it's not going to be too difficult if you're just going to be a person who types into a prompt to get what you want, right? Like that's not a difficult skill to learn, right? So it's going to be much harder for someone to like you know, who doesn't know how to build a program to like use AI to build a good program, right? But the thing is about AI is that it still keeps like fundamentally it just basically makes stuff up when it doesn't know, right? So you will probably bump into lots of places where it's just going to hallucinate into a bug, right? And yeah. So, you know, if I'm required to use AI to do my work faster at work, right? It's not too difficult just to adjust my work pattern to do that, right? You know, um, but also, yeah, I think there's bigger problems to worry about, right? Like, the bigger problems to worry about is some guy at the top being like, oh, I can just get rid of all my employees now, right? When really they can't. And they end up just like setting stuff on fire. Um, that's more of a bigger sort of concern. But, I don't really worry about that stuff because, otherwise I wouldn't be faithful. Would be, yeah, would be like, if you have fear in the world, that means you don't believe in God, basically. That's the basic idea. Meant to just fear God alone and not the world or anything like that. But yes, I don't worry about that stuff. And the reason why I don't worry about it as well is because if you worry about there being no jobs, people just give up, right? So I always tell the young people when I see them who are doing IT, they're like, "Oh yeah, AI is really scary or whatever and that." I don't know if I have a job, and I'd be like, you know, focus on doing the best you can and learning the best. And don't worry about the problem of it disappearing. Do it because you love it. And if all the jobs disappear, sorry, all those people who are thinking the jobs will disappear are going to give up, and there'll be more room for you to be there. So it could just work itself out. Um, yeah, the privacy around training yeah, it's crazy. It just sucks how we live in a world where that's the thing. Could you imagine, right? You're using this AI system on your code base, and what it's doing in the background is scooping up your code and then training itself on that code as well. Can you imagine that? I'm sure they're doing that. Like, yeah, making their use of the product, basically, or the users of the product. Anyway, but yeah, I think the bigger concerns to worry about is as well is people want to put chips in their brains. Transhumanism. They're building this AI stuff, and it's basically like, man trying to become God. Man raise fist up at the air at God and say, I don't need you, God. We're smart, we're intelligent. People get so prideful because man make phone, because man put man on moon, and we think we're the bee's knees because we have this technology, and all the people in the past are dummies. But intelligence takes many different shapes and forms. Um, you know, people in the past had really good memories, memorizing lots of different things, probably, right? And we don't know if we go back thousand years what that looked like. Yeah, make electron go purr. Yep. But yeah, there's a lot more things to be concerned about. Like, you know, the creator of yeah, you think of Universe exactly. Yeah. So you know Sam Altman, the head of ChatGPT, if I'm gonna give him that name. Um, he wants to put his brain in computer. I don't know if he actually believes that it will be him in the computer. If he does, that would be crazy. But you can imagine that's the guy that's sort of like making decisions around AI. You know, like it's a bit concerning. And you've got Elon Musk making Tesla bots, and he's also wants to make the brain computer interface. You know, I'm sure people are going to be like, "Oh, I can't live without my prosthetic robot arm." You know, not prosthetic. Sorry, that's the wrong word. I meant they will feel like they need to become part robot, and they'll have to cut off their human arm, which they've already got. Right? It's different if someone's lost their limb. But, you know, I think people are going to get into a condition where they will want to, you know, claim from the government and be like, oh, I need my robot arm. And then people are going to like go full machine, some people. It'd be like Cyberpunk. You would do it if you knew my instance is retained. What do you mean by retained? You would upload your. Oh, wait. So you would say if you don't have to get killed to be uploaded in the computer. So you would do a copy of yourself in a machine. Hmm. Yeah. I don't think I would do it. I don't think I would do it. I think it'll be very difficult for me to work with myself. Plus, it would be like really weird. Um, yeah, what else? Yeah, the other thing as well, which is kind of crazy, you have to be concerned about is they're doing like DNA manipulation. Like, how long until someone's going to be like, my children need bunny ears? You know, it'll happen. Give it like a few years. What I'm waiting for is Revelation. Hang on, not 13. We keep going to 13. Is it 15 or 16? Wait. We can't do the NIV. Why do they keep doing this? People need to stop reading the NIV. Go proper. This is the bold judgments. There we go. This is another indicator that Jesus is coming soon. So the sixth angel. So this is the bold judgment. Like if you read these guys, you'll be like, how can anyone survive? So basically, it's the amount of people that are going to survive the tribulation. Very small. So the sixth angel poured out his bowl, and the great river Euphrates and its water was dried up, so that the way of the kings of the east may be prepared. And I saw three unclean spirits like frogs coming out of the mouth of the dragon, and the mouth of the beast, and out of the mouth of the false prophet. Or they're the spirit of demons. So, you know, frog-like beings. Like if you was going to describe an alien back in 2,000 years ago, it would be frogs. But yeah, so I reckon right. River Euphrates. If you look on due to like global warming, it will dry up at 2040 according to Google. So this like there's a few things, right? Either this happens before 2040, like tribulation before 2040, or the river Euphrates dries up and then gets water again, or Um, wait, what's the third one? Uh, yeah, that's basically, isn't it? Yeah, so it either has to happen in the next few, like, next 14 years, basically. Or the river doesn't actually dry up by 2040 and it gets delayed. Yep. It's an interesting one. Just putting it there. That's what most people need to be concerned about. Is Jesus coming? Because the tribulation is big, it's rough. You need the blood of Jesus to set you free. And if you have the blood of Jesus, set you free. You don't have to endure the tribulation because Jesus saves us from the wrath. And you'll be raptured up in a glorified body, not in a glorified body made with human hands and robot parts and DNA manipulation. No, you're made with a glorified body from God, which makes you live for eternity. You can never sin anymore. But, it's the Daniel 9 prophecy, which calculated the exact arrival of the Messiah, Jesus Christ, to the day. Is it Daniel 9? Yeah, 70 weeks. So after 70 weeks, so the 70th week is the tribulation, 69 have been fulfilled. There'll be an end of transgressions against the law, so no more sinning. Right? Reconciliation for iniquity, so all those wrongs that you've done in your life, they'll be reconciled, sorted out, mate. And everlasting righteousness. Good times. All in glorified bodies. And Jesus be ruling for 1,000 years on the earth. Be incredible. But yeah. And the entry price is just simply believe in Jesus Christ and his finishing work on the cross. That he died, lived the perfect life that you could never live. Lived the perfect life that you could never live. And paid the price for each and every one of your sins through his blood. And that Bible verse, Leviticus 17:11, was fulfilled. For the life of the flesh is in the blood, and God has given it to you upon the altar to make atonement for your souls, for it's the blood that makes atonement for the soul. And God has done it because he loves you. John 3 verse 16, isn't it? Here it is. For God so loved the world that he gave his only begotten Son, that whoever believes in him should not perish but have everlasting life. For God did not send his Son into the world to condemn the world, but that through the world it might be saved. So essentially, the first time Jesus came is to provide the free gift to get into heaven, because we can do it by ourselves, saw us suffering, dying in our sins. The only way to be set free from them is by the power of God, by the Spirit of God, by Jesus Christ's sacrifice on the cross. And the next time Jesus comes, he is going to judge the world. So there's only a finite amount of time left for that, guys. So while you're still here, please consider it. There's plenty of evidence how that Jesus is real. Just look at Bible prophecy. The Bible's not been changed for over 2,000 years, and there's Bible prophecy, which is there's a few things, right? There's Bible prophecy which has predicted. There's in Daniel that predicts from the time of building the temple, time for the decree to build the temple, to when Jesus came and died. Jesus on the cross, right? That was prophesied exactly to the day. You can look at that one. It's in Daniel 9. Just give it a search. And there's copies of the book of Daniel which have survived for over 2,000 years before Christianity became a thing. I think also as well, you can find in Daniel, the book of Daniel, there's a prophecy which predicts from somewhere like the decree to build the temple or something like that to when Israel was born as a nation in 1948 to the day. You can't make it up. It's Bible prophecy because the Bible's real. Plenty of other evidence as well. Shroud of Turin, look into that. It's quite possibly the burial cloth of Jesus. And yeah. Right. I gotta go now. Oh, what, tomorrow? But it was a good stream. Got a CPU side of this stuff is mostly done, just gotta fill in the properties, then everything's uploaded to the GPU. And then next stream we can basically sort out getting this hard-coded data actually being rendered on the GPU. Then after that we can move into doing our first detail material, which will probably be that Moss one again. But yeah. Right, have a good night, guys. God bless you all. And I'll see you all on Tuesday. There's a schedule down below, you know. And there's also a Discord where you can come and chat in the meantime. And if you want to support the channel some more and get access to the codes to run on your own local machine, you can follow that link up there and support the channel. Appreciate you all. Much love.